The next definition is the leading coefficient test. As x moves without bound to the left, x is going to negative infinity, and to the right, it's going to positive infinity. And so the graph will eventually rise or fall. This behavior is referred to as the end behavior of the function. So basically the behavior far left and far right. So we want to know what happens to the graph on the left side and on the right side. Does it fall? Does it rise? So we have steps to determine the end behavior. So the first step is you want to find the degree of the polynomial. Then from this degree, we're going to have two options. Number one, if the degree is odd, then it will have a certain behavior. And number two, if the degree is even, then it's going to have a certain behavior. The second thing that we need is the leading coefficient. And here we have two options too. If the leading coefficient is positive, then something happens with the behavior. If it's negative, then something happens. So we're going to find out what that something is. In order to figure out these behaviors, I want to use 4 functions that we're familiar with. You can try to memorize the definitions, but since we know what these look like, then this will help you determine the behavior of any graph. So we know that f of x equals to x squared is a parabola. The leading coefficient here, or the degree, is 2. And we want to say that this is even, because we're going to use that in a little bit. And then then the leading coefficient is 1, and that leading coefficient is positive. Okay, so let's look at the graph. So the graph for this parabola looks like this. Okay, so the behavior when a function is even and positive, when the degree is even and the leading coefficient is positive, is going to be as follows. If we look at the graph, all the way to the right side, we can see that this graph here is rising. And all the way to the left side, this graph is rising. So we'd say that the graph rises right and rises left. Okay. The next one is f of x equals negative x squared. And so the degree for that is 2, which is still even. And the leading coefficient is negative 1, which is now negative. So the graph, I'm going to call this B. So the graph for negative x squared looks like this. Okay, so when you have a graph with degree even and negative coefficient, then we say that the graph, so to the right it's falling and to the left it's falling. So the graph falls left and falls right. Okay, so in both situations, when the degree was even, the graph does the same to the right and to the left. So it either falls left and right or it rises left and right. Okay, the next one is the x cubed. So the degree here is 3 and the leading coefficient is 1. So the degree is odd and the leading coefficient is positive. So this graph looks like this. It's one of our parent functions. So if we have an odd and positive, an odd degree with a positive leading coefficient, then we say that the graph to the right, you can see that it's rising. Graph rises, right? And to the left, we can see the graph is falling. Okay, the last one, f of x is equal to negative x cubed. So the degree here is 3. Leading coefficient is negative 1. So we still have an odd degree with a negative coefficient, leading coefficient. So the graph for this one will look something like this. Okay, so if your degree is odd and you have a negative leading coefficient, then we say that the graph falls right and rises right, rises left. So rises left, falls right. Okay, so again, you can memorize these 4 statements here, or what I like to do is, since we know what these graphs look like, then no matter what problem you have, you can refer back to these graphs.